Good morning, everybody.
Good
Hello.
morning.
Okay, welcome everyone. How is all doing in class today?
Good.
Good? Okay, that's good. That's good to hear. So today we are going to continue with our fifth module. We started working on discrete probability distribution last time. And today we are going to continue with a special type of discrete probability distribution called binomial probability distribution. So this is one of the special examples of the discrete probability distribution. So first, we are going to look at something called the binomial experiment, because we have seen in discrete probability distribution, we talk about the probability distribution of a random variable x. And that random variable is the numerical value associated with the outcome of the probability distribution. That's what we have studied in previous class. So here in binomial probability distribution, our random variable x will be the result of the binomial experiment. So first, we need to know what is binomial experiment. So when we say binomial experiment, the first thing is the number of trials must be fixed. Say, for example, you are answering 5 multiple choice questions. Okay, you are answering 5 multiple choice questions where there are 4 options in each. So that means if you are answering these questions and you are absolutely guessing on all 5, okay, you are doing a total of 5 times. You are guessing for the 5 times. First guess on the first question, second guess on the second, then third, fourth, and fifth. So number of trial is fixed. That is the first condition. So answering those 5 multiple choice questions by guessing should be a binomial experiment. Let's see whether it satisfies all conditions or not. The second one is each trial must have only 2 outcomes, that is either success or failure. So if you are trying to guess the answer for 5 of those questions, then what happened is you may make it right or it will be wrong. So there are only 2 outcomes, whether you'll make it right or wrong. Okay, you'll have the probability of making a success or failure. Third one, the outcome of each trial must be independent of each other. Suppose you guess right in the first answer, and when you try to guess the second, it doesn't mean that you'll make it right or wrong, which depends on the first answer. In fact, when you're trying to guess the answer for these 5 multiple choice questions, the answer for each will be independent. Your guessing or the result or the probability that you answer will be independent of each other. And then the probability of success or the probability of failure should remain same for all trials. So for question number 1, the probability that you make right is 1 out of 4. If there are 4 options, then one of them is correct. So it is 1 out of 4. Similarly, it is 1 out of 4 in second also, because there are 4 options. So that remains same. And the probability of failure will be 1 minus 1/4. That will be 3/4. So if P is the probability of success and Q is the probability of failure, note that if you add P and Q here, P plus Q must be 1. Okay, P plus Q must be 1. That means when you know the value of Q, I mean P, to find the value of Q, you subtract that from 1. So that's why P plus Q is always 1. The reason is, you have seen in the previous chapter, the total probability is always 1. So it is just because of that, the value of P plus Q is 1. So this is the basic idea about the binomial probability distribution. So based on this experiment or binomial experiment, we are going to define that binomial probability distribution. Whatever we have studied here is binomial experiment. Binomial experiment should follow these 4 criteria. And if these 4 criteria are true, the experiment is a binomial experiment. The random variable associated with the outcome of the experiment is binomial random variable, and the probability distribution associated with that is the binomial probability distribution, which is a special type of discrete probability distribution. Before I move on to the definition of binomial probability distribution, Are there any questions on binomial experiment?
No.
Okay, great. So here we are going to define binomial probability distribution. So as I said before, the outcome in the binomial probability distribution, okay, the outcome in the binomial probability distribution is the result of the binomial experiment. So outcome of binomial probability distribution and then corresponding probabilities is called the binomial probability distribution. So this is what it is. Just to simplify it, if you have the random variable x, and this random variable x is the result of the binomial experiment, it can take on different values. So x may have a couple of values. So if you think of those type questions, you may answer none of them correctly, maybe one of them correctly, two of them correctly, three of them correctly, four of them correctly, or all five correct when you try to guess. So the random variable will take these values 0, 1, 2, 3, 4, 5. And the corresponding probabilities. If you list the corresponding probabilities, if we find the probability in each case, then this distribution is called the binomial probability distribution. Okay, so the outcome of the binomial experiment and their corresponding probabilities is known as the binomial probability distribution. Now, in order to find the value of the probability, so if you want to find P of X here in this class, we'll be using calculator to solve all the problems. So I'm going to give you this definition here. And you can add this to your note catcher. This one. Px, the probability of X successes in a binomial probability distribution is equal to, we use the binomial PDF function in our calculator, binomial probability distribution function in our calculator for n trials. N is the number of trial, P is the probability of success, and X is the number of successes we are calculating. So make sure you add this formula to your note catcher. Px equal to binomial PDF, parenthesis begin, n comma p comma x. N is the number of trial, p is the probability of success, and x is the number of successes that we are calculating. Okay, are there any questions here?
No questions.
Awesome. Okay, now we are going to use this formula and solve a problem, but make sure your calculator is ready because we need calculator for this. So here is the example. Surgery at a hospital has 95% chance of success. So if we look at any surgery at that hospital, the probability that the surgery will be successful is 95%. So if we want to write the value of the probability P, the probability of success is P. So we can write here, P is equal to probability of success, okay, is equal to 95% or 0.95. That is the probability of success. So if P is 0.95, you know that Q will be the 5% remaining, which is 0.05. Probability of success is 95%. So probability of failure will be 5%. Now, surgery is performed on 4 patients, n equal to 4. Okay, n equal to 4.
That says 3.
Say that again. The
Oh,
surgery
there's 4. Never mind. It was blocked out by the thing.
It's okay. Surgery is performed on 4 patients, so n equal to 4. But what we have to do is we have to find the probability of the surgery being successful on exactly 3 patients. Here it is 3. So surgery is performed on 4, but we have to calculate the probability that it will be successful in exactly 3. 3 will be successful, 1 will be unsuccessful. So X is 3. and X is equal to 3. So that information is given in the problem. Okay. Now, what we know is if we want to find the probability of X successes in binomial experiment, okay, if we want to find the probability of X successes in binomial experiment, we have seen the formula in the previous slide. What we do is we do binomial PDF function in our calculator, okay, binomial PDF, then we'll have NPX, NPX. So that is what we are going to write here. If we substitute, X is 3. So now it is binomial PDF. The value of N is 4. Value of P is 0.95. And value of X is 3. Before we simplify this further, are you following it so far?
Yes.
Okay,
Yes.
now we need to type this in our calculator. So you know that I don't have any calculator to share online. So I'm going to talk slowly here so that you can find this out in your calculator. Okay. So what you'll do is in your calculator, when you just look at your calculator, do you see VARS there? Just see. Do you see VARS?
Yes.
On the third, I should say, row, right? On the third row, there is VARS. Do you see that? Everybody?
Yes.
Yes.
Okay. So that is something. Just above that VARS, what is written there? Just above VARS, what is written there?
Distribution.
Distribution, that's right. DISTR, that is distribution. So here we are talking about distribution. So we need to access that, and we need the binomial distribution. In order to access whatever is written above the buttons, okay, we have to press second, because color of second and color of distribution is the same. Do you see that? The color, when you try to match the color, it is the same. So that means what we do first is you press second, and then press VARS. When you press second and VARS, you'll see the list there, right?
Yes.
Okay. But when you look at that list, you don't see this binomial PDF. But if you look at all the way down, there is a downward arrow. That means if you keep scrolling down, you should see binomial PDF. Do you see
Yes.
binomial PDF when you scroll down?
Yeah.
Okay, binomial PDF. That is what you'll see there. Once you see that with the parenthesis there, you can hit enter. Okay. After that, you can hit enter. So after that, you hit enter. Let me write here. You hit enter. When you hit enter, what do you see in the next screen?
0.171475.
Hold on. I don't know what you're saying. After you hit enter, what do you see?
It says trials P
Okay,
X
good.
value
So,
paste.
right. So you have to fill that. So you have to fill that screen. So here the number of trials is 4. So plug in 4 there. And then the probability of success is 0.95. So value of P is 0.95. Put that. And then the value of X is 3. X value is 3. Put that. And then you paste that information on the main screen. Paste. When you paste it, do you see this one on the screen? What I have typed here. Do you see this on the screen?
Yes.
Yes. Now hit enter to get the answer. What did you get?
1.8785E/06.
No, you did something wrong. Did we get 0.1715?
Yeah.
Okay. So if you followed my direction properly, you must get 0.1715. Now listen one thing. After this class, from today's class on, you'll see that there is very intense use of calculator. Very intense use of calculator, okay, after this chapter. So what I want all of you to do is, because if I'm just saying this and if you try to follow the direction on your calculator, it's not that easy to follow. So what I want you to do is make sure you watch those recorded videos, okay, watch those recorded videos under the module before you come to class, so that it is easy for you to follow my direction on your calculator. Okay, so here we get a probability of 3 successes out of 4 surgery is 0.1715. So what we have done here is we use the binomial function, binomial random variable, and we use the formula for binomial probability distribution to find that value, probability of 3 successes out of 4. Before we move any further, are there any questions? Calculator is something you really need to watch D12 video and then learn from there, okay?
No questions.
Thank you. Okay, so we are going to work on one more example so that you'll be a little more used to in using your calculator and calculating the probability. So let's move on to next example here. Let's see. A survey found that 15% of US adults say internet is the major source of news for them. So when asked to the US adult, 15% of people say that they use internet for the source of news. That means the value of P is 0.15. Probability that they say that they use internet as the source of news is 0.15 or 15%. So that means if P is 0.15, your Q will be 100 minus 15% will be 85% or 0.85. 0.85. Okay, you randomly select 5 adults. That means you are asking question to 5 adults. That means N is equal to 5. When you ask these 5 people whether they use internet as the source of news or not, they will say yes or no. Okay, they say yes, I use internet as the source of news, or no, I don't use internet as the source of news. But the probability that they will say yes is 0.15, and probability that they will say no is 0.85. Okay, so you randomly select 5 adults and ask them whether internet is the major source of news for them. Now we have to find these probabilities. But before we answer these questions, let me write these random variable X. When you think of the random variable, when you ask to 5 people, maybe none of them say that they use internet as the source of news. None of them, 0. Maybe 1 will say that I use internet as the source. Maybe 2 of them will say that they use internet as the source. Maybe 3 of them. Maybe 4 of them say yes. Or maybe all 5 of them yes. Okay, so now we have to find the corresponding probabilities P of X. We have to find the probability P of X. Now what I want you to do is, I want you to complete this table. I want you to complete this table using calculator. Okay, complete this table using calculator. But make sure when you write your answer this time, let's write the answer up to 5 decimal places instead of 4. Okay, 5 decimal places instead of 4. So in order to find the first one, please follow along with me so that it's easy on your calculator. So to answer the first one, again, you go to second and then vars. Second, vars. Go to binomial PDF. Binomial PDF and fill the information. Here N is equal to 5. Probability of success is 0.15. P is 0.15. And here for the first one, X is 0. X is 0. You paste that and enter. And tell me what did you get? When you put 0, what did you get?
0.44370.
0.44371 when you round it to five decimal places. When you round it, okay? 371, you got it right. Now, if you change it to 1, if you plug in x equal to 1 there, what do you get? Please complete the table just like that. Put the values and complete the table. All of you, please. If you're not using the table, you don't know what is going, I mean, if you're not using the calculator and if you're just copying the values, you don't know what is going on here. So make sure you use calculator and then write these values. So once you get the values, check with my values on the table. So that's what you should get. If you enter the values correctly on your calculator, that's what you should be getting. Okay, I hope you are done with this. So are you getting those values? Beautiful people.
Yes.
Okay, good. So all you have to do is you have to plug in the values and then create this binomial probability distribution. So for this problem, where the random variable is from 0 through 5, if we create the probability distribution, this is the probability distribution. Now, based on this probability distribution, we can answer these 3 questions easily. Yes, Isabella.
Why is 5 0.0008? I got 7.59375.
Okay, so for the last one, you said you got. Let me write what you got. Tell me what you got.
7.59375.
Okay, 7.59375. What is there after that?
E -5.
Okay, E -5. Okay, when you see E -5 on your calculator, this is the answer in scientific notation. Meaning of that is this is a very small number like 0. So many zeros. How many zeros? If here is 5, 4 zeros, and then the number will begin after that. Numbers are 7, 5, 9, 3, 7, 5. That's the meaning of that. When you see -5, that means you'll have 4 zeros, and after that you have the numbers. Now, if you try, this is in scientific notation, okay? Now, if you try to write this to 4 decimal places, see 4 decimal places, 1, 2, 3, 4 is up to there. And when we go up to 5 decimal places here, we want to round this number. And if you look at the number after that, the number after that is a 5. So if the number after that is 5 or more, we increase this number by 1. So it will be 0.0000, then 8. So that's what I have written here. Okay. Yeah, because the value is given in scientific notation. And when we change it to decimal and round it to 5 decimal places, that is what it will look like. I hope you get that, Isabella. Did you get it?
Yes.
And thank you for asking. Maybe there are some people in the class who are not just asking. So thank you so much for asking. So everybody has idea about that. Okay, now let's answer the questions. So here in part A, the question is, we have to find the probability that exactly 3 of them responded yes. Probability that X is exactly equal to 3. X is 3. So in place of this, X is equal to 3. So if you look at the table, what is the probability that when X is equal to 3, what is the probability? When X is equal to 3, what is the probability?
0.0248.
That's right. So 0.02438. So probability that exactly 3 of them responded yes is 0.02438, which is here from the table. So we're using that table to answer the question now. If you look at B now, B says we have to find the probability that at least 3. When you say at least 3, that is 3 or more. Meaning of at least 3 is 3 or more. So if you look at the table, 3 or more will be 3, 4, and 5. That means we have to add the probability of these 3. So when we say probability that X is 3 or more, probability that X is greater than or equal to 3, that is the meaning of that, right? 3 or more means greater than or equal to 3, is the sum of these 3 probabilities, which is 0.02438 plus probability of 4 is 0.00215, and probability that X is equal to 5 is 0.0000 and then 8. So now we need to add these all. Please add those in your calculator.
Point 0.02661.
0.02661, is that what you said?
Mm-hmm.
0.02661. Yes, you're right. That's the correct answer. So when we are asking or when they ask for probability of at least 3, meaning of that is 3 or more, or mathematically we can write that as the value of X is greater than or equal to 3. That means that is 3, 4, and 5. So when we add them together, it is 0.02661. Are we clear?
Yes.
Okay, very good, very good. Now let's look at C. In part C, they says we have to find the probability that fewer than 3 of them responded yes when they are asked whether they use internet as the source of news. So fewer than 3 means less than 3. Fewer than 3 means less than 3. Less than 3. We can write like this: probability that X is less than 3. And if you look at the table, less than 3 means 0, 1, and 2. Okay, less than 3 means 0, 1, and 2. So we have to add those 3 probabilities. So probability that X is equal to 0 is 0.44371. Probability that X is equal to 1 is 0.39150. And probability that X equal to 2 is 0.13818. So now we need to add these 3 numbers. Now please add these numbers.
Point 0.97339.
0.97339. You are right. That's true. Very good. Very good. So you can see that to answer these questions, it is not difficult. But in order to create this probability distribution table that I've created here, what I used is I use my calculator to create that table. So that is something you need to learn. You must know how to create this table. And based on that, we can answer these questions easily. Okay. Any question on this example?
No.
No question. Okay. It's not that difficult. It's quite easy. So let's move on to next one. So you have seen that in the discrete probability distribution, we can find the mean, also called the expected value, and the standard deviation of the discrete probability distribution. So in the previous class, we have the discrete probability distribution given. We make all those tables and then use the formula and found the mean and the standard deviation. But for binomial probability distribution, calculation of mean and standard deviation is much easier compared to that. So if you want to find the mean, you can see here, mean is simply n times p. If you multiply the number of trials with p, that's how we find the mean. Okay, please highlight that. Similarly, if you want to find the standard deviation, it has the square root. Standard deviation is the square root of n times p times q. Quite easy. And then the variance will be the square of that. When you square that, it will be just n times p times q. So the variance will be n times p times q. So please highlight these three formulas. You'll see that the calculation of mean and standard deviation is much easier for binomial probability distribution compared to the basic discrete probability distribution that we have studied in previous class. When we don't know which type of discrete probability distribution is it, then we use that formula. But if we know that it is binomial, we use these formulas. Okay, let's take an example so that this will be more clear. Here is the example. It has been reported that 65% of adults age 70 and over. So here we are focusing on the age group 70 or more. So in that age group, 65% of the adult, they got their flu shot last year. So value of P, probability that they have the flu shot or they got the flu shot is 0.65. 65% got the flu shot. That means if you want to know how many of them or probability that they are not vaccinated against flu will be 1 minus 0.65 or 100 minus 65, that is 35% or 0.35. Because P plus Q is 1. So P is 65%, which is 0.65, and Q will be 100 minus 65%, that's 35% or 0.35. In a random survey of 200 adults, this is your n equal to 200 in that age group. So when you're asking these people whether you are vaccinated or not, when you ask these 200 people whether you are vaccinated or not, they will say yes or no. And the probability that they will be vaccinated is 0.65, and they will not be vaccinated against flu will be 0.35. Now, what we are asked to do is, we are asked to find the mean, variance, and standard deviation for this binomial probability distribution. So the first one, we want to find the mean. And you know that mean is n times p. Quite simple there, n times p. N is 200. Multiplied to p is 0.65. So if you multiply that, 200 times 0.65 is 130. So out of 200, on average, we can say that 130 of them are vaccinated against flu. Okay, that is the mean number of people who got their flu shot. N times P, 130. Next one is we are asked to find the variance. Variance, let me write here. Variance is the square of the standard deviation given by the formula n times p times q. N is 200, p is 0.65, and q is 0.35. If we multiply all that, it is 45.5. So the variance, which is the square of the standard deviation, is 45.5. And finally, we are asked to find the standard deviation. Let me write that down. Standard deviation, denoted by sigma, is the square root of n times p times q, which is the square root of, here we got the value of n times p times q, which is 45.5. So we'll take the square root of this using our calculator. And if you try to find the square root, it should be approximately 6.7454. That means the standard deviation is 6.7454. So that means if we try to look at the mean, it was 130, and you have the spread within one standard deviation of approximately 6. That is the meaning of that. So you can see that compared to if the normal, the distribution is just given and you're asked to find the mean and the standard deviation, and you don't know what type of discrete probability distribution is that, like in the previous class, you'll use the formula. But when you know that it's a binomial probability distribution here, because the table is not given, okay, it is quite easy to find the mean and the standard deviation using these quick formulas. Are there any questions on this one?
No.
No question. Okay, that is wonderful. So you can see that the binomial probability distribution is pretty quick compared to what we have done in the previous class. So you can clearly see that with this, we are done with the 5th unit. But as I told you previously, what I want you to do is for the next chapter, okay, for the next chapter, as it is heavily based on calculator, we'll be using a lot of calculator to solve the problem. Make sure you watch those lecture videos before you come to the class so that it will be easy for you to follow. Otherwise, I'm going to warn you here, there are chances that you'll get lost. What is this man talking about? Okay, so please